Welcome, everyone. My name is Patrick McFadin. I do a lot of things at DataStax. One of the things I've always done is work on Apache Cassandra. I've been working on that project for over 10 years now. I also work on Pulsar, Apache Pulsar, do some work in Kubernetes around the Kubernetes projects. I have a couple other projects, which I will mention later, that I work on. I do a lot of talking about various things around data and doing things at scale, cloudy, et cetera, et cetera. So today I'm going to do a little dive into building open data services in Kubernetes, which is a massive talk, which we will glide through in 45 minutes, hopefully. And if you can, if you have questions along the way, just drop them into the little Zoom question Q&A thing, or if you throw something in chat, I'm watching that too. I have that up. So, I expect that there will be some, and if you have some, feel free to bring them up. So let's just get going here. So first thing, like I said, I love data, and I do talk about it quite a bit. I had a pretty successful series on O'Reilly Learning. It's still there. If you're on O'Reilly Learning, don't go look at it because it's old. It's really old, and there's new things coming. But one of the things that I was always interested in is building stacks. Data doesn't always just, and you'll see some of how I think about data, but data is not just an island. It needs to be moved around and dealt with in different ways. And so one of the things I have always been a big proponent of is building up these architectures to do things with data. And right now I am in the middle of writing a book with my good friend Jeff Carpenter, who is a Cassandra the Definitive Guide author, managing cloud native data on Kubernetes. It's in early release right now. I think like half of the book is out if you want to go look at it, which, because you're here and you're hanging out with me, early release is hilarious. I mean, we type stuff up, we do some minor editing. Our editor does some editing, spell checks and stuff like that. But boy, it is just Kobe tossed right over the wall into this early release thing. So you get it really is raw. It's totally raw. So it's still cool though, because we got a lot of good response on it so far. There's people saying, hey, here's some things I would love to know more about. And it helps us as we're designing this book. It turns it into an iterative thing. So spoiler warning, today's part of that. I want to talk about things that are relevant to me as I'm writing this book. And writing a book is really like, I don't know why I even thought I should do this, but I did it. And you learn some things along the way and you start forming questions. And this is part of my open conversation around this. So let's just dive into this. So let's get into the key part of this is data. Data is not optional in how we operate the world today. And it's in every single app. And every time I say that, somebody's always got an app that doesn't use data. Okay, like somebody was showing me like some app on their phone that is like it's a balance, like it shows like it's a bubble level, but it sends back telemetry data to iCloud. So there's still data involved in that. And that's a bit of a stretch. But I mean, mostly if you're working for a company, and it's, if you go by that thing where every company is a software company, then every software company is also a data company. And you have to be in 2022 when this talk was given. And because you can't survive in a world where you're not looking at your data, using data, interacting with customers, and interacting with customers always generates data. And personalization, all of those things that we talk about in digital transformation, basically, hey, we want to get over what Amazon could do to us. Like, digital transformation is about becoming more in tune with your customers and things like that, and being more agile and being faster. And the thing about being faster is it's not just, that Facebook had this thing where it's like, we want to go so fast that we break things, run with scissors, things like that. Well, Yeah, but most times, when we're building applications, it's like we know, like we're building these kinds of applications all the time. This web and mobile microservices kind of applications, your AKA your Spring people out there, shout out. IoT applications, they all have one thing in common. They all use a database. And what you don't want to build is systems that fail all the time, but you still need to go a lot faster. And a lot faster that's your speed advantage in trying to overtake your competitors. And even if you're like, well, we don't have a lot of competition, you do, because everyone has a competitor, and this is a part of just being in business anymore. Now, if you're an open source developer and you're developing open source products, shout out, love you. And that's not as much of a thing, but mainly what I'm talking to are people who are building the full stack or going out there and building applications, or a part of that team that's building applications. So with data, we have, I'm just use this real simple example of like something like an IoT application that takes temperature at a time and stores it. You're probably talking about a database when it's real simple. I put data in, I get data out, walk away, super simple. And there are plenty of applications that go that way, which is, a very common use case. However, this is more of what's probably going to happen is we have these more complex cases for our data where one piece of data goes in, and then we want different kinds of data out based on that one piece of data. So when the temperature goes in, I'd like to get the temperature out. Oh, but I'd also like to know that the high temperature is today and the low temperature is today. And that generally means more complex machinery that has to deal with this. And this is more likely what you need. And that complexity is the thing that we're always trying to hide as operators. My background is in operations and building systems architecture. We want to hide the complexity, the pay no mind to the data center underneath. But that complexity has to be managed, and it can be a huge problem. So this is how we built apps, right? And I'm sure you've all been here, where we do the whiteboard thing. And this is one of my favorite things. It's getting on the whiteboard, brainstorming with other people in my company, or with app developers, and we just start going through the process. And the process is really cool because we start defining things like, what does our application need? And we work with business owners or product managers, things like that. The scaling requirements, like how successful is this going to be? Is it something we have to account for with scaling? And most applications do have some sort of scaling requirement. I started out in my development career working in the .com industries, and it was like, we got tens of users, and that was really exciting. Yeah, I mean, millions of users is not a thing. It's just like, that's almost like starting. That's your first day. So we always have to think about scaling, and it's always going to be up. And finally, deploying options. Like how do we want to deploy this? A cloud is probably the answer, but it's not a complete answer, because cloud is like that. It's kind of just your raw materials. What are you going to do, and how are you going to do it? And when you're done with this whiteboard thing and you go through this, then you get into this like, here's my wonderful architecture. And this is and it's funny because I was building this out. I'm like, this is a pretty simple architecture, but I mean, look at all the boxes and lines flying all over the place. And it's because when you think of like your complex data needs, you may have complex architecture to service all of those things. And no one solution or no one database, no one streaming tool is going to solve all your problems. I think that's just fallacy. And if anyone tells you that they solve it all, then they're probably lying to you. And that's okay, because you can go off and do that, but we have great options that do work well together. So for instance, using something like Pulsar for your streaming, moving data from point A to point B. Like I told you I work on that project some. And Flink for stream processing. But what if I want to save my data into Cassandra, or I need to put it into an object storage for offline that later I can use Spark or Ray to do in-depth analysis. And then I store my features for my online feature store into Feast, which Feast is an online AI data store, feature store. And so, these are all these things that are like linked and put together, but pretty practical. But invariably, whenever we build this architecture diagram, then we got to go meet with the ops team, right? And I used to be on one of those chairs where the timekeepers are right now. This is the timekeepers from the Loki series, if you haven't seen that. But it's always a negotiation, right? It's like, here we go. Okay, this is what we want. Can we do this, right? And so we take our architecture diagram, and this is generally how the conversation goes. It's like, yeah, we don't do Pulsar, we only support Kafka. Or yeah, Feast, right? Never heard of it. We can't support it. We don't know what that is. or hey, can we just, instead of using Cassandra, can we just use Oracle? Because we've got tons of Oracle DBAs. Why don't we just use Oracle? We have a huge contract with them. So we begin this negotiation. But when we're done, and a lot of times these negotiations happen because the operations are so hard. And I completely understand that. One of the things that I always felt as someone who ran operations for a long time is that one of my jobs was to block developers from doing crazy things. And some of the crazy things they would do is like, hey, I found this rando project on GitHub that I want to use in our next top line production product. And like, no, like as one maintainer and it barely works. I don't think so. That's the thing that we get to do. But it's important that we remain flexible to the things that do work, because there are a lot of things that work great. And to say no because you just don't understand it or it's hard to work with, that's a hard thing, because that puts people in the same company working towards the same goal at odds with each other. We want to work with our developers, and developers need this kind of fluidity and speed. We need that, just like we need near real-time applications, we need near real-time with our developers. So when you get done with your infrastructure, it's set in stone, right? And changing that is really, really difficult. And I'm sure there's a lot of you out there that have gone down this path many times, and you've built up this whole infrastructure plan where you have tons of infrastructure that's solid as a rock. Okay. Whew. That was back then. Today we have Kubernetes, and I don't need to tell everyone how awesome Kubernetes can be. Although I know there's a lot of naysayers. It's like, man, that's a lot of complexity in infrastructure just to get a couple of things running. Yeah, kind of, sort of. But I will just say right now that if you're running your own Kubernetes right now, like you're running all of that from scratch, you're probably doing it wrong. Every cloud provider has their own version of Kubernetes. There's some great Kubernetes distributions out there. Kubernetes can be way easier to run. So let's just assume that you did a good job of picking a Kubernetes provider and you're just applying stuff into it. So let's go there. So Kubernetes, what does it mean for us as application producers, runners, developers? It's taking this thing, and we just saw this great talk by Colin about like taking these Docker containers or containers in general, applying some magic, YAML occurs, and we're building virtual data centers. And I think this is really an important concept to get across, is that when we build virtual data centers, it's really critical to think of like what we're trying to replace. Cloud providers provided a data center for you, and they gave you all the stuff inside of it at a premium. But now we can do different things with that. So I want to build a virtual data center where I have some input and output. And that virtual data center includes all the things it need. Kubernetes provides name services, networking, security. I think that this is really the way to think about it. And thanks for the shout out, Colin. Is we're building a virtual data center where back in the day I would build out virtual machines, that encapsulated all that. Then we containerized that, made it easier and more portable. But now we're making these portable data centers. I could take a well-constructed YAML file for a Kubernetes deployment and deploy it on Google, on Amazon, on Azure. They all should work. And this is why I'm excited about it, because I am lazy. I had a professor who used to say this all the time, and I'm going to say anonymous because I'm sure he wasn't one who made it up. If he was, I'm sorry, Dr. Sharika, wherever you are. But progress in technology is when we have the ability to be more lazy. And that's like, I know none of you all are lazy, but I think we embrace laziness. It's like we're trying to do more with less, right? And Kubernetes is a fast track to lazy, because all I really want out of my cloud providers is compute, network, and storage. I just want to rent that. And, or if I'm in a data center, my own on-prem data center, and I'm buying racks and racks of servers still, I still want to manage my compute, network, and storage, because that's what costs money. And I need to manage my costs. And how I do that is I use Kubernetes to efficiently manage my costs. And whenever we get roped into this thing where we're kind of dumping our stuff into cloud data services, that's bad, because now data services in clouds means that you are in the walled garden, and you say goodbye to open source, because you've now departed the land of open source and gently landed into the walled garden. Try to get that data out of there, and think about like what that means to you for portability. If somebody changes their policies, or if someone changes their pricing or whatever, and things happen all the time. I don't know if you remember this back in the day, but Target's CEO, Target, the company here in the US, retailer, their CEO decided he didn't want anything in Amazon's web services. AWS was a no-no. So they, as a company, moved everything to Google, because Amazon was competing with Target, and he's like, I'm not giving them a dime. Happens all the time. Walmart runs in Azure and in Google, not in AWS, and they move around because of competitive pressures on other fronts. And as an infrastructure person or developer, you got to be ready to pick up your bags and run when the CEO says we're going to go, or find a new job. So let's start thinking in services. So this is the fast track of getting ourselves in frame of mind to being cloud native. And I said it's cloud native TM, because this is I think the big shift that has to happen as infrastructure people, because we start with this, right? Oh my God, I mean, how many IP addresses have you memorized in your life? Probably way more than you should. And it's just how we've operated for so long. IP addresses are a part of our configuration. And we've gotten away with it because IPv4 is pretty reasonable. I can remember a lot of IPv4 stuff, especially if I get the first two quads. But IPv6 is ridiculous. I'm actually kind of assuming that the reason we're not going to IPv6 quickly is because no one can memorize these numbers. I would run IPv6 in my house if I could remember some of these numbers. And I'm sorry, there's just not enough green tea to make me remember all that. Okay. And then finally we have ports too. So clients typically have always used, or still use, an IP and a port. So, this is a Python connecting to a Cassandra cluster. Creating that cluster object requires an IP, at least one IP of a running Cassandra node. And I mean, the driver is pretty smart. It will figure out what the cluster looks like and populate. It does a dynamic population of how many different nodes are inside the cluster. So that's cool, but it's still all IPs. It's still an array of IP addresses. And you have to specify the port. And then whenever you connect to the cluster, you're connecting to an IP. So, and none of this looks weird, because this is how we do things, right? But it opens up a bunch of doors. Like, are we using the right version of driver? Oh man, driver hell is a thing, because when you're connecting to, say, a database, I just use database as an example, like Cassandra. If you're using the wrong version driver to the wrong version of the cluster, you're going to be in trouble, and you have to manage all of that. IP ranges do change, especially if you're using any kind of DHCP or something like that. They just don't. I mean, how many people use DHCP in a dynamic environment like that? It's hard. And then firewall rules, which are a bit more of a problem, because especially if you have fixed IP and ports, then you have to deal with all that. I mean, these are some of the things that we tried to get away from with Kubernetes. We're just like, look, I am sick and tired of typing in IP numbers to a firewall. Let's do something different. Okay. And that's where Kubernetes really said, hold my beer, because services, I mean, it's hard to find an IP address inside of Kubernetes. You can find them, they exist, but it's really based on service names. And that is super cool in my book, because when I'm doing any work with Kubernetes, I I just want to give it a name and I want to run away, because it's all in a configuration file, which we will talk more about soon. But it gives us this ability to create a virtual data center using name services that is built in, because Kubernetes, when you deploy a Kubernetes cluster, name services are inside. That's a part of the deployment. So when you bring up your Kubernetes cluster or you're connecting to one in the cloud, that Kubernetes cluster comes with a name server free of charge. There you go. And when pods start up and you're building a service definition, you can do load balancers. Colin talked about traffic in his his talk. I love traffic. That's more of ingress, but ingress connects to services, which is all name based. And we're still stuck using ports, but a lot of those ports can get eliminated eventually. But named services, and there's namespaces inside of Kubernetes. It just makes things a lot easier. And we're starting to see how I can get more lazy now. Now, lazy factor one, I no longer have to memorize IPs. Yay, team. And I don't need to, I don't want to. I just want to bring up a pod and have it automatically connect up to the service definition. And then I want to be able to use it. And that makes my life a lot easier. When I ran infrastructure, I had an entire network team, and they were in the data center, and they had cables and diagrams and firewall rules and memorize their Cisco commands, because that's how you did things. None of that's needed anymore. When we create a virtual data center, that's all done by the robots. And it brings me to this whole concept of, the data service is, I think that the logical extension of where we are going with this. Data services allow you to connect using HTTP, as well as more traditional protocol formats, like HTTP protocols like REST, GraphQL, gRPC are much easier to work with, because you have one single port to deal with. They're easy to encrypt, because you can use Acme and certificate manager, cert manager. Those are all easy to use, and they, more importantly, are what developers want to use. They don't want to go back and use drivers and figure it out. They want to use things that will get them there quicker and fast, these fast moving, easy to iterate on protocols. And some data services still do provide like SQL, CQL, document modeling, Gremlin, that sort of thing for data services, but it's to support the legacy. And every time I bring up legacy support, I still remember that IBM had their biggest mainframe sales year in 2020. I am not kidding. So there's a sadness. And what was interesting is I worked with this team at Facebook quite a few years ago, but they built a service called Accio, and it was one of the first real data services that I was exposed to, and it got my whole gears turning. It's not a Kubernetes product, but essentially what they do is they built it to accelerate their developers. Developers just had an API to connect to, and the data was worldwide. It was like it fronted a Cassandra database. Cassandra was one of the databases that they worked with, but developers didn't have to think about data locality, anything like that. Accio did all those things for them, and that's awesome. That makes your developers super lazy. They can just go build code that makes money instead of figuring out how to run infrastructure. And now we're getting into this now. These are so much easier. I can put my data in. I'm using curl because I'm old school like that. But think of it like this you could use this in JavaScript and Node.js and Python and Java and Rust, because you're that cool. But I just connected to a domain name or a name data service and used a URL and put my data in. If I want to get my data out, I connect to the same data service. And that data service is not an IP address. It can be fully dynamic. Things can happen underneath it, which I don't know what's going on. That's one of our best things that we can do as infrastructure people, is to manage a lot of infrastructure without anyone knowing that it completely blew up, right? That's the best thing about data services. You can have a completely horrible day in infrastructure and be totally fine, because hey, the service is still up, right? Still getting on a ping 200, yay, go team. And that's the hiding the complexity. And I love this part of it because this is kind of the fun puzzle. It's solving the puzzle. It's not like Wordle. If anyone's hooked on Wordle, I'm sorry, but it's that puzzle we solve for our developers. And developers want this thing, which is the iceberg. It's easy to use, but there's a lot of messy details. We're building a virtual data center. Essentially, we're building out what Amazon, Google, and Azure are trying to sell us, which is this, oh, it's just click a button and it's there. It's just a name service and everything happens underneath. It's just, don't worry about that. It's pay no mind to the droids in the backseat of my speeder. But, to put it more in defined terms, we're talking about cloud native developers want HTTP, right? And your wonderful our data architecture is underneath all of that. And what I'm pushing, and everyone, I think this is, I'm being pushy about this, but make sure it's open source, make sure it's declarative, make sure it's service-based. This is what gives you the most flexibility in your future and definitely makes it portable. This is what makes it so that you can make a choice. You don't get locked in, you don't have a hard meeting. So let's go back to our wonderful data architecture that's going to help us track weather data around the world. And really what we're going to do here is just put this whole thing in Kubernetes. Now, I know you're saying like, well, one does not just wave a magic wand and put your infrastructure in Kubernetes. No, you don't. And it's a competency that you have to build. And it takes time. Did I mention I'm writing a book about this? Since last year, I've been doing infrastructure for a long time, more than 20 years. And I'm still learning things. And that's what's fun about this field, is that you never stop learning. There's ways to do it. So let's dig into this a little bit. So I told you I work on a couple other projects. This is part of my open source world. Is I work on a project called Stargate, which is it's all HTTP APIs for Cassandra data. It does document, gRPC, REST. And I also work a project called Cassandra, which is taking Cassandra and making it Kubernetes-fied. Is that a word? It is. But it includes all this stuff. We say it's batteries included. It makes it so you can do a Helm install Cassandra, and you get everything that someone who's well seasoned in running a Cassandra cluster will have. It really makes it super easy. And DataStax, we have our Astra Cassandra as a service. You can go rent Cassandra if you just don't want to run it. But Cassandra is mostly a lot of open source bits from that. We run our entire business on Kubernetes. We do data on Kubernetes every day. This is why I can tell you with all assurance that it is possible. But we've open sourced a lot of those bits into Cassandra, and there's more coming. But if you think about these are the kind of things that you can't just take a thing like putting Cassandra into Kubernetes, tons of work. But projects like this, they exist in all different data products. And I'm really proud of what we're doing with Cassandra, because we're working pretty tightly with the Kubernetes community to make something that actually works. So it gives us this idea of where we're at is instead of just saying, here's our thing and set in stone, we get to define and refine. And it's iterative, just like we do code, it's iterative. Agile Code has been around for a long time. Sprints and doing everything once a week, and running everything through Git and CI/CD. That's all been great. I mean, you can do a lot of application. You can do applications really fast that way. But how has that really been translating into our infrastructure side? And I would say it's starting to look really good. Because in this case, here's if you're going to deploy a Cassandra cluster, one of the things you can put in there is how big do you want your cluster to be? And what if I say today I need it to be 3? Well, tomorrow I want it to be 5. Well, it's just a kubectl will apply, or you can use other tools, which I'll discuss here in a minute. But I'm continuously refining these things. I'm not going out and buying a server. I'm not deploying. I'm not going out and firing up an EC2 instance. None of these things. I'm just changing a number in a YAML file, and it's evolving to what I need it to be. It's a very simple example, but it translates. There's a lot of things we can do that are just like this. And it gives us this ability to move faster, to be lazier. I've run a lot of Cassandra in my day. And the fact that I can expand my Cassandra cluster by changing a 3 to a 5, that's just magical. I think it's amazing. So, and there's tools out there like Argo. I'm going to particularly call out Argo because it's a very popular project in the CNCF. But Argo does some really cool stuff around GitOps. If you are not familiar with GitOps, it's this idea that you can store all your configuration or Kubernetes configuration in Git, and a tool like Argo will watch a Git happen, or your Git activities happen. And so it's basically like, if you use like Jenkins, Jenkins has that thing where it does a build based on PR merge. Well, Argo does that for your infrastructure. And I've seen some really cool utilizations of this, but thinking about it in terms of how you do this define or refine is that, going back to that original meeting where we're all sitting around on the whiteboard, I guarantee you we got it wrong, right? That is not perfect, but that's okay. I mean, that was a good guess. What if it's 10% wrong? Easy enough. What if it's 50% wrong? It's going to be harder. But as you're building your application, you shouldn't have to stop the world to refine your infrastructure and have a change control meeting and all those other things that might have to happen. It should not put your project status in the red. You should say, oh, you know what? Instead of doing it this way, we need to do it that way. Put it in your YAML file, PR merge into Git, and all of a sudden Argo will take that, and it gives you these abilities to do things like in dev and staging, like output into different areas. It just keeps things moving along. And if it doesn't work, you can roll it back. I mean, all of those things that we've done in application code, now we're doing in our application infrastructure. We're putting the entire stack to work in the same way. And that is a superpower. I know organizations that do this, and they're really quiet about it because it is a competitive advantage. Someday we'll probably see more talks about it when it's not so much of a competitive advantage, but today it is a competitive advantage because they're able to outpace everybody. And we're getting to the point now where we take these YAML files, right? And this is my pain of mind about what actual YAML is. My dream is to actually build a YAML file that I can do something with and build a virtual data center, right? And just one YAML file. I think so far it's going to take quite a few YAML files, which is fine. But I'm on a mission to build this Uber YAML file that I can just apply and just have things happen. But regardless, configuration, this declarative infrastructure that you're building, can be applied to your virtual data center. So then you're saying, I want to build this virtual data center with input and lots of different output. If you think about the way we need our data to work with, with our input data, like what we're trying to accomplish, we are adding an enormous amount of complexity into our systems. And that complexity can be managed declaratively. That is the beauty of using something like Kubernetes, is that you can be very precise. And if you make a mistake, you can alter it, and it's repeatable and it's portable. You notice I don't have one single cloud provider on there. That virtual data center I can run that on my laptop. That architecture that I showed you before, do not run that on your laptop. It will blow it up. It's a lot of pods, and I was a little sad about that. I did try to make as much possible. I can run an entire Pulsar cluster on my laptop, but that's probably about 8 pods and you can run them on a smallest size, but that's what makes me think like, man, do I need to get like one of those gamer laptops with like 56 cores and 64 gigs of RAM? Ooh, yes, I do. But Kubernetes, I actually use a lot of GCP now for that. I just I set it up and I run my YAMLs in that, pay for it by the hour. But here we are again, is we're back to this. And it's very interesting is that, and I should point this out, this is not just some rando architecture that I'm throwing out there. I don't want to just say, well, here's possibly some things. I picked these pretty importantly, I picked these because they all have a Kubernetes implementation. Pulsar first class is Kubernetes. There is a project built Helm chart. Flink has an enormous amount of operators and Helm charts available. Feast, same. Ray was almost built for Kubernetes. And if you're not familiar, Ray is a way you can run, you can do Python code at scale, cluster Python code. It's kind of an alternative to Spark, but it's strictly geared towards running Python code at scale. It's really popular in the data science community. And, it's one of the projects that I've been watching quite a bit. But Spark has 3 deployment modes, one of which is Kubernetes, and does some really cool stuff with that. And what's interesting about Spark is it's pushing Kubernetes in a different direction as well with schedulers. It's changing the way schedulers are working. There's some great open source projects around Spark, Unicorn and Volcano.sh, which are alternative schedulers that work at large scale analytics. So all of these things work inside of Kubernetes and have Helm charts and operators to make it easy for you. So you're not just installing software into Kubernetes, you're actually working with tools that work with Kubernetes. Now microservices, I mean, that's a pretty easy one. There's plenty of ways to make that work. And then for object storage, mostly I say rent that. Go rent that from your cloud provider of choice, object storage. You could use things like Ceph, MinIO is another one, although I have a hard time recommending anything that's not Apache licensed anymore. They've switched to AGPL and I just like, they're dead to me. Ceph is still, I think, a valid choice there. But generally just renting that's a rental for sure. Every one of these is a rental, by the way, too. And
Patrick, yeah. We do have one question that just was posed.
Oh, common security errors. Yes. Yeah, this is just generally, if you're doing infrastructure on Git, make sure your Git ignore is really good, because you do not want to put things like your private key into your Git repo, especially even if it's private. Just don't do it. Those are just some common things. Also, PEM files, you don't want to put those in there. They should all be generated. I think those are the 2 main ones that I think of a lot. And if you have a file with a password in it, then that's your problem. But just be very careful and aware of the fact that when you're putting things into Git, assume that someone could see them that doesn't need to eventually. Your infrastructure is sacred, but your security, your private keys and that sort of thing are just irreplaceable. I've had to go through a security incident where one of our private keys we didn't know if it got compromised, but it was put in a place where it could have been. So we just did the precautionary thing and replaced all of it. And man, that's painful. So don't do that. Thanks, Elizabeth, for that question. And thanks, Kiana, for letting me know that I had one.
No problem. And letting you know now we have about 5 more minutes left.
5 more minutes. Okay, so big finish. So the other thing is, notice what I did there. I switched Cassandra for Vitesse. It also gives us the ability to change things up. And like, if you're like, you know what, Cassandra's great and all, but I like MySQL. Boom, Vitesse is your choice. And this is that portability is not just in where you run it, but how you run it. It's because I'm using services, and a lot of these things work well with service naming, and if they can connect, that's great. It changes the ability how quickly you can move around. what if you just like, wait, we don't need predictive analytics or anything like that. We're just going to remove all of that. That's easy to do. Redeploy it and tear down that infrastructure. We are at the point now where this kind of thing is really possible. And I'm excited about the future of where this is going. I think that, and I'm pretty much at the end here, but I think the things the takeaways that I want you to have here, and again, this is a work in progress, and I would always love to hear what you think about this, and I'll give you my contact stuff here in a minute. But so the takeaways I would love for you to have today are, just go for it. Deploy your entire stack on Kubernetes. It's time. You need to do this, and this is the future. It's how clouds are being consumed. It's how we're doing compute, network, and storage, and managing our resources. It's not a fad. It's just how things are going. Cloud is not a fad. Kubernetes is not a fad. Go for it. And embrace the idea of service names and making sure that you're using service names and not IPs. It's a hard habit to break, right? It's not like, getting off a coffee or something like that. It's not that bad. But yeah, I mean, it's hard for me. I still use a lot of IPs inside of my own house. I have a pretty complicated setup for my home automation system. And I slowly started moving over them into a name server and using traffic internally, but I still want to use an IP address because that's the machine, right? And then I am advocating for developers, and I think this is what we all have one common goal, which is developers need to go faster because that's good, but they also need something reliable. And this is what they need. And what they really want is HTTP APIs anymore. And that's fine. I mean, because they work great, they're routable, they're securable, and there's lots of things that can work with that. I mentioned Stargate, the project I worked on. There's other ones out there like Apollo that do this kind of stuff at scale all the time. So just let's give developers what they need to go faster. And I'm going to be an advocate for Apache license open source. This is open source 101. Here's your 101. Insist on Apache license open source. I don't like, like how there's a lot of different Apache-like ones, but Apache license is pretty solid. It's version 2, by the way. It's really it's a clean open source license. It lets you do what you want. It gives you that freeze and beers and freeze and freedom. Companies that deploy products using Apache license, things can do whatever they want. You can do whatever you want. That's the way to go. These middle in between licenses like BSL and AGPL, I think they're confusing and they're not really open source. That's my opinion. And then finally, it's this thing about define and refine. And I think that's the most important thing you can do here is thinking about, and like every time I define something, I'm always ready to refine it. So just finally, thank you for everyone. You can find me on Twitter, Patrick McFadin, LinkedIn, Patrick McFadin. My name is pretty unique, just spell it right. And if you ever have any questions and you want to email me, Patrick at DataStax, real easy. So thank you, everyone.